Hello everyone, my name is Susanna and I'm a PhD student at the Swedish University of Agricultural Sciences. So here's my title, but what I'm going to do now is just talk a little bit about the research project which I'm involved with and show a little bit of the implementation I did so far with the Hydrus 2D constructed wetlands module. So our research project is about on-site treatment of greywater. What we're doing is small-scale treatment for single households generating greywater, such as remote Swedish summer houses or households in low-income, water-scarce countries. So those households, they will use a dry toilet, and all the wastewater that they are generating in their households is going to be bath, shower, and laundry water. That is greywater. We want something that is really simple, robust, and low cost. So we are looking into vertical flow filters. I'm going to go ahead and show you our experimental setup. So this is probably not that impressive to the constructed wetlands people here who have a lot of plants and things. We just have those columns. And they are 1 meter in height and they have a 20 centimeters diameter. They are filled with filter material up to 60 centimeters. We are looking at 3 different filter materials. The first one is sand. Sand is really well known and is commonly used in constructed wetlands. We want the sand mainly to be our reference. What we are really interested in is looking into whether charcoal or bark could be functional as filter materials. They do have a lot of good qualities, such as very low bulk density, so they are easily transported. And in countries where sand is not available or very expensive, you could go ahead and use bark instead. So here we have a bark filter and the charcoal filter. There are actually 2 more filter columns here, but they were not used. So here is a sketch of our experimental setup, which hopefully shows things a little bit more clearly. The filters were intermittently loaded 3 times per day from those sprinklers, which were connected to a pumping system with a heater, so the incoming water held a certain temperature. This was done automatically by a computer. And the filter effluent was collected in a bucket standing on top of a scale, which recorded the weight and time once every minute. So we had a very good observation of the cumulative flow through our filters. And our filter experiment was run for 112 days. And we had measured a lot of the hydraulic properties of the material, such as the porosity and the saturated water content and so on. So, a colleague of mine measured the influent concentrations and the effluent concentrations. She measured a lot of pollutant concentrations, such as the BUD, CUD, total organic carbon, inorganic phosphorus, total phosphorus, various nitrogen species, and total nitrogen. So we had a very good idea of what was going into our filters and what was coming out of our filters. But we asked ourselves, like, what is really happening inside our filters. So to get a better quantitative understanding of the treatment processes, we set up the vertical flow sand filter in the Hydrus CV2D interface. So that is the constructed wetlands module. I'm really not going to go into detail about all the processes and components. The speakers before me did already some of that. So I'm going to go ahead and show you some results. So the first thing I did was to set up a hydraulic model using the Van approach, of course. So as I said, we had a really good observation of our cumulative flow. So this is measurements from 1 day from the sand filter. And the loadings were done here, here, and here. You can actually see that the second loading is not really showing. It was really small, only 0.1 liters. And there was a lot of splashing on the filter walls, so we have some problems with the experimental design. But never mind, the simulated data, you can see that it matched quite well with the experimental data. We used the air entry value and the pore size distribution index as fitting parameters for this. About the reactive transport, Here's just some simulated and measured mean values of the filter fluent concentrations. I want to mention that when we used the constructed wetlands module, we were just using the standard process parameter set. So what we have here, it was quite successful for nitrogen and phosphorus, but for the CUD it was not that good. Here, the constructed wetlands will divide CUD into readily biodegradable CUD, slowly biodegradable CUD, and inert CUD, and we had some problems with getting that to match our measured values. But the total CUD is somewhat similar to the simulated total CUD is somewhat similar to what we measured. So I think there was a problem with the simulated heterotrophic microorganisms, because they just grew and grew and grew. We can see during 112 days there was continuous growth. One could expect that a steady state would be after 30 days or so. So what we really want to do now is to characterize the microbial biomass in our physical filters. We are setting up a new experiment, and we are discussing some method to use so that we can really quantify the exact, well, not the exact, but the amount of biomass that we get in our filters when we are irrigating them with greywater. And when we have some observations of this, we can use them to calibrate some of the parameters of the constructed wetlands module. And when we have done that, I do think that we will get much better results here. And when after our calibration, we could use the simulations to predict the outcome of different loading regimes and gain some insights on the optimal filter design. But as I mentioned earlier, our sand filter is really just our reference that we want to use to compare with our other data from the bark and charcoal filters, which are much more interesting. So what we want to do in the future is see if we can use the Hydrus software to simulate also our bark and charcoal. And this will be quite a challenge, I think, but mainly a really good quality of the bark and charcoal is that those materials have really large specific area. So each charcoal and bark aggregate will have a lot of micropores, and probably there's a lot of going on there, like transport within the aggregates. So there's a lot of action there that needs to be simulated. I think I talked really fast, but I guess that's just good because we were after the time. Yes, thank you.
Thank you very much. We have time for quite a few questions. Yeah?
I wrote my email here, so if you have some questions later, you can send me some emails.
Okay, thank you. So next presenter is